Okay, so let's continue with some more rules with polymorphism. One of the rules is what can you make variables of a certain reference variables of a certain class what can it point to? So maybe I'll start out with some examples. So in this example we set up, let's take a look again. This is explained in the previous video, but let's take a look at it. Class A, just class by itself. Remember, class A implicitly extends the class object. Class B extends class A, which extends object, so indirectly B extends object. But the main thing here for this example is just that B extends A, and then we create an A object which is of type A, and we create when we actually create the object, it's also of type A. By polymorphism you can do this. You can say B is of type A, but when you create the object you can create an object of type B and assign it to A. So that's definitely doable. So what kinds of things can we do? We can say A is equal to B. Is that okay to do? Yes, because they are both of the same type. They're reference variables of the same type, and so you can do this. So even if B is actually of type uppercase B, A can point to an object of type uppercase B because of polymorphism. Okay, so B can be assigned to point to an object of type A or B, same thing with lowercase a. So then you might say, well, can you do B is equal to A? Turns out, yes, you can. So all this is saying is exactly the same as before. B is of type uppercase A is of type uppercase A, sure. You can have B point to A. Now A, in this case, A we know is an object of type uppercase A. So both A and B will actually point to objects of type uppercase A. Now if A were actually an object of type B through polymorphism, is this allowed? Sure, because that's just polymorphism. If A is of type B, then B can refer to an object of type B. What you cannot do is this. So if BB is explicitly typed to be a variable of type B, it cannot point to an object that is possibly an object of a superclass type. So in this case we know lowercase a is pointing to an object of type A definitely, and Java explicitly says a subclass reference data type BB is of type B can definitely not point to an object which is of type superclass. Alright, so that's what this rule is talking about. You cannot automatically make a reference variable of a subclass type point to an object of its superclass type. So suppose that supref is a reference variable of a superclass type, then if that supref points to an object of its subclass, you can use an appropriate cast operator on supref and make a reference variable of the subclass point to the object. What is this really saying? It's easier to sort of see it in code. What you can do is you get an error message here when you do this BB is equal to A. What it's saying is that you can do this and make the error message go away. However, since A is actually pointing to an object of type A, this will not work. If you try to do this, it looks like it compiles okay. You can save it. Remember that with Eclipse, as soon as you save it, the Java compiler kicks in, compiled it, and actually the code actually compiled. But we know this should not work, and when we run this, we'll get an error message saying class cast exception. A cannot be cast as this. You cannot do this operation is what it's saying. Okay, so, and that's what the notes are saying. If superf does not point to a subclass object, in this case that's what superf is, our A object, and you use a cast operator on superf like we did in our example to make a reference variable of the subclass point to that object, then Java will throw a class cast exception indicating that the class cast is not allowed, and that's exactly what we saw. So here's the question: can we do this? And you might say, well, A is of type A, B is of type A, and then this definitely should not work. Well, it turns out, if you remember, go back up here, B is actually, even though it's of type A, it's actually pointing to a B object, uppercase B object. So let's see what happens. So this is the kind of thing that I'd expect you to at least be able to understand why this case it works. Like no error messages. Change this back to A. Compiles just like with B, but when you run it, as we saw before, you get an error message. Change this to B. Compiles and runs without any error messages. I hope that makes sense. The difference is between A and B is that B actually refers to a B object. Okay, so that's what all of these sentences are really saying. Now you might want to definitely go over all of these statements, make sure that they make sense to you. Okay, it might take a little bit of reading. So there is an instance of operator. This is a reserved word in Java. It determines whether a reference variable that points to an object is of a particular class type. So you can do things like this. If A is of type A, you can see this should be true. A instance of A is true. A instance of B, definitely not true. Okay? There's no way in this case that A is of instance of B. Now B instance of A, yes, it's true because B is, remember that inheritance is described as being an is-a relationship. What that says is anything of type B, anything that is of type A can point to something of type B. So now B is definitely an A object. Is B an instance of a B object? In this case, yes, it is true. So if you print it out, you get this: B is an A, B is a B. And you can check that out by running this. And you say BB is of type B. Is BB instance of A true? It turns out yes, it is true. So you get this: BB is an A. And that's one way of understanding the is-a relationship that we get with inheritance. BB is also an instance of type B. So both of these are true for BB and for B. Okay. So instance of determines whether a reference variable that points to an object is of a particular class type. This expression varies to true if P points to an object of the class box shape, in this case P instance of box shape. Otherwise it'll evaluate to false. So inheritance does factor into those calculations for instance of. Alright, so now let's take a look at this completely new topic. Maybe some of you have seen abstract classes, abstract methods, and interfaces. And I'm guessing that for a lot of you, maybe it's completely new. So an abstract method is a method that only has this declaration but no method body. So abstract methods have no method bodies. And it has to be declared abstract. Well, actually we'll see. In some cases, in interfaces, you don't have to have the abstract, it's sort of implied. But whenever you see a method without a method body, it's good to put in abstract. For abstract classes, you definitely need this. Actually, this is flipped around. This should say public abstract void print, I believe. And just like this, public abstract object larger. So methods without method bodies should have the abstract keyword, and this should be flipped around. I believe it should be abstract void insert. Okay, so a few typos, but if you get an error message when you do something like this, just flip the order. It should work. Alright, we'll see abstract classes in a lot more detail much later on, but abstract classes are classes that have at least one method member that is abstract. If you have one method member that's abstract, the whole class becomes abstract, and you have to use the keyword abstract in its heading. So just one method without a method body means the whole class becomes abstract, and you have to use abstract. That will get rid of error messages if you ever use, when you get around to setting abstract classes, you'll see this. An abstract class can contain instance variables, that is non-static data members. That's another way of referring to them. Can have constructors. You can have abstract classes with constructors. You can have abstract classes with finalizers. We haven't really talked about that so much. Maybe we'll do that later. And you can also have non-abstract methods in abstract classes. So if just one method is abstract, then the entire class becomes abstract, which means that you can have any number of non-abstract, or they're also referred to as concrete methods. You can have 100 concrete methods, but then if you have one abstract method, the whole class becomes abstract. An abstract class can contain abstract methods, sure. If a class contains an abstract method, the class must be declared abstract. So you can contain abstract methods. So basically says if you're an abstract class, you can or not contain abstract methods, but if you have an abstract method, the class has to be declared abstract. You cannot instantiate any abstract classes. You cannot create instances of an abstract class. You can only declare a reference variable of an abstract class type. You cannot create instances. So later on we look at this example where I make this shape class I change the visibility, and then much later I have this class, shape class, which I convert to an abstract class, and it really simplifies the design. And this is an example of an abstract class. I made this get perimeter abstract, and so as a result this entire class has to be abstract. I also make get area abstract. So this is the order you want. You want to say public abstract and then the return type. So I think in some of my slides I might have had a typo, but it has to say whatever visibility and then abstract and then the return type. I think if you try to flip the order, probably won't work. Yeah, gives you an error message. Alright, just checking. So you want to have abstract first and then the return type. Okay, so you can instantiate an object of a subclass of an abstract class, but only if the subclass gives a definition of all the abstract methods of the superclass. So what it really means is if you have an abstract class and you're going to create, for example, a circle class, you say that circle extends shape, it's an abstract class, you have to implement all of the abstract classes, well there's just two of them, if you want to create instances of this subclass. So to be able to create instances of circle, all of those abstract classes have to have, all those abstract methods from the abstract class have to have method bodies. So let's take a look at this example next in our next video.